Good evening, everybody. We are about 10 minutes out from tonight's puzzle for Advent of Code being released, so let's get the stream started. Welcome to all our viewers. Remember that you can always find the replays of these streams up generally just later in the evening on YouTube at my YouTube channel. That's youtube.com/spoonboy42. And all the code that I write here will get committed to GitHub. And my GitHub is, I'll just put it on the screen right now. It is github.com/Craig-Chasseur, and this repo is AOC 2020. So you can check out everything that we do up on GitHub. So we have about 8 minutes till tonight's puzzle unlocks. In that time, I'm going to go over a few more tweaks I made since last night's stream, particularly to the Day 4 solutions and the Part 2 solution for Day 4. So on last night's stream, I talked a little bit about using regular expressions to validate those passport fields. And I went ahead and did that. But I realized that I couldn't, at least it wasn't simple to have just kind of one class to manage a regex to validate a field, because some of the fields you need to parse an integer and make sure that it's in a certain range, and that's kind of beyond the capabilities of regular expressions just by themselves. One field at least, for height, you need to see what units it's in, and the range of valid integers is different depending on the units. So what I wound up doing here is making this interface class field validator, and it keeps track of the bit position, of that check bit for those bit fields that we OR together to see and to basically make a set and make sure that we have all of the correct passport fields filled in. There's a no-op version here that's just used for country ID. It just always says that it's correct. There's this one where the field value is just a pure integer and it has to be in a certain range. So instead of using a regex, I still just use the abcel simple a to I function for that and check that it's in range. There is the regex version where we give it a regex pattern and make sure that the full match goes in there correctly. And then for height, that's probably the most tricky one, where we have a regex pattern here, and what the pattern looks like is we're looking for one or more digits here, and then we're looking for this either cm to indicate centimeters or in to indicate inches. So up here we have just the height and the units variables to capture those two parenthesized groups in the regular expression. We match against the pattern. If it doesn't match, obviously it's not valid. If the units are centimeters, then we check if it's in the range of valid values for centimeters. Otherwise, the units must be inches, or this pattern wouldn't have matched. And we check that it's in the valid range for the inches. So then the passport fields class itself gets way simpler. We have this static map from strings, which are the names of the fields, to the respective validators for the fields. And everything in this is just allocated with new, and it's never deleted because it's static. It has lifetime for the entire program, so you don't really need to delete it. But in here you see for the first three fields, which are all different kinds of years, we use that int field validator just with their different ranges. For height, we have that specially written height validator that checks the units. For hair color, eye color, and passport ID, for all of these, we just use a regex. So hair color is a £, followed by exactly 6 hexadecimal digits. For eye color, it is exactly one of these valid strings. So that vertical bar is just indicating, this or this. For the passport ID, it's exactly 9 decimal digits. And for country ID, it is that no-op validator, because we're not actually doing anything to verify country ID. So that is how this looks using regexes. I think that, you know, with this scaffolding in place, and now that I have the RE2 library to use regexes in C++, linked into my repo, I think that this it's kind of easier and more straightforward than writing all those custom validators now. And we have those in place in case we want to use regexes on any future puzzles. So there are two more things that I also did to clean up this solution a little bit. And you can basically just see them in main. So one is that for the I/O routines, a lot of these previously I had them returning absal status or for like production quality code where you want to be able to be resilient to errors and want to be able to check if something did an error and recover from it and not necessarily crash the program then. I think that's still a valuable thing to do, but then you actually have to write all the error checking logic and check if the status is okay. For these puzzles, I decided that's kind of overkill, and it's going to be simpler and faster for coding if we just have these check themselves. So they now use the check routines where they previously would have returned errors, and they'll just, stop the program if there's ever an I/O error of any kind. So that kind of applies to everything that reads data from files. All these routines where previously we had status ors and we had to check that they were okay before we could access the value, we just return a flat value now. The other thing that I did is I added this split by empty strings function. And what this does is it takes a vector of strings and it gives you like the sublists of them split by empty strings as delimiters. And you'll probably recognize that as the exact format that we had for the different strings of password fields in the day 4 puzzle. I'm not sure if we're ever going to need to use that again, but you can see the implementation here. I'm not going to go into too much detail on this. You can read the code on GitHub. If you do have questions, feel free to send them to me. But you can see how we use it in the day 4 solution, in the modified version of the day 4 solutions here, is that now we can just split up the passport strings, and we just delegate all the complexity of that to this function, and that makes this main function that much simpler for the day 4 solution. So yeah, we've done a lot of cleanup on day 4 at this point, and I'm pretty happy with that right now. Day 5, as you'll recall from yesterday, it was pretty simple. It was basically, parsing some binary numbers and then, doing some relatively simple stuff on them, either finding the max or finding a gap in the sequence. So not much more to do there. We have about 1 minute till the puzzle unlocks for day 6. So let's go ahead and make a new folder in the repo for day 6. And let's make our minimal program here. And let's make the build file for it as well. Go ahead and format that. Okay, and we have just a couple of seconds now till the puzzle unlocks. Just in time. Day 6. So your flight approaches the airport, where you switch to a larger plane. Customs declaration forms are distributed passengers. So we've got 26 yes or no questions marked A through Z. All you need to do is identify the questions for which anyone in your group answers yes. So your group is just you, doesn't take too long. Person next to you is experiencing a language barrier and asks for help. For each of the people in their group, you write down the questions for which they answer yes, 1 per line. There are 6 questions to which anyone answered yes. Okay, so eventually we've collected answers from everyone, from every group on this plane. Hey, blank line separation! Weird how that turned out, isn't it? Yep. For each group, count the number of questions to which anyone answered yes. What is the sum of these counts? Okay. So, man, I feel like a prophet for coming up with that that new split by empty lines routine. That's going to save us some time. So we check that we have the expected number of arguments. All right. Just do our basic I/O here. We're going to get the lines from the file that we pass as the first argument to the program. And then we're going to get the groups by splitting up those lines. I don't know why it chose the version and type traits. It should have gotten the one from utility, but whatever. So there's a couple of ways that we can do this. We can use a set of characters. We can use bit fields again in a low-level way, or we can, and then just do like a population count of the set bits, because there's only going to be up to 26 for the characters. And I have a feeling that that might be a little slower for this first one, but it's going to be faster when we actually have to maybe do something a little more complicated with it in part 2. So let's go ahead and do that. We'll say group for a group of people. We will use uint32 because we need 26 bits. That's the next largest size to represent the fields. Initialize that to 0. In this constructor, we will take that group string, and then what we're going to do is for each line in that, for each character in that line, we're going to get a bit position. And the really easy way to do this is all of the ASCII characters A through Z are consecutive. So like if we want A to be 0 and Z to be 25, we just use subtraction in the character domain. So the position is going to be C minus the literal character A. And then we will OR a bit at that position into answers. And then to count those up, so I built-in, is it built-in? Don't fail me now. What is, okay, I want to use the built-in pop count thing that is provided by the compiler. It is not really standard C++, but it maps to what we want. So built-in pop count. These are the GCC documentation, but it should definitely also apply to Clang. Yeah, okay. So this is going to return the number of 1 bits that are set in the argument. Which is our answers thing. This actually maps on at least on x86 CPUs and probably a lot of architectures. It maps to a very fast built-in instruction to do that too. That was apparently requested by the U.S. government to do something fishy with encryption. I don't really know the details of it though. Sorry. Group string in groups. And what is the puzzle actually asking us to do again? So we want to sum the counts for each group. Okay, so total equals 0 to start. And then we will add to the total. We will parse a group from that, add its number of answers, and then spit out the total. Okay. We're going to, so to actually build this program, we're going to need to put the right deps in here. We're going to need absale strings and both of our little utility libraries. Just going to copy and paste those from previous day. And I am going to take the test input from the puzzle and just give ourselves a little test first. Still had yesterday's in there, but do Bazel run, use our LLVM compiler config, optimize it, why not? Day 5, part 1, run it on the test input, check fail. It's day 6 that we want to run, not day 5. And that gives us 11, which is what the puzzle says. Did I actually download the puzzle input yet? No, I didn't. Let me download it. Day6.txt. That's what our input looks like. Let's go ahead and run it on, run our program on it. So 6,775 is the answer that it gives us. Let's see if that is correct. It is! All right. Let's move on to part 2. Okay. So you finish the last group's declaration. You notice that you misread one word in the instructions. You don't need to identify the questions to which anyone answered yes. You need to identify the questions to which everyone answered yes. Okay. Okay, so I'm going to go ahead and copy the code for, so yeah, we need to find the questions to which everyone answered yes, and it's actually going to be a pretty simple modification of our program, I think, to make this work for part 2. So I'm going to copy the code for part 1 to use as the basis for part 2. Just refresh our view here, get into part 2. So now this representation of the answers, you know, it's basically instead of putting together an OR for each individual person's stuff, we're going to put these together using AND. But to start this, we want to have everything set, I think, because so what I'm doing here is I'm initializing this in the first place before we start any parsing to the maximum possible value for uint32, which is all the 1-bit set. Now, as soon as we AND that together with the bits that we have for an individual person, it's going to change to just that individual person's answer, and as we continue ANDing that together with the bit map for the answer questions for each person in a group, we're going to get the conjunction of all their answers. So basically we're doing set operations here, but we're doing them just on a bit set, because this is simple enough that that was the most straightforward and almost certainly the fastest way to do it. So for each group, we're going to start off with this person's answers with 0, nothing set, and then we're going to OR in all the stuff for that individual person. And then what we're going to do is we're going to AND that with the group's answers. And it is honestly as simple as that. I think we have our part 2 solution now. We're just using bit twiddling to do set operations. So so with the original test input that we got, according to the website, the correct answer should be 6. So let's just verify that with our new program. That's what we get. Let's do it with our test input. Okay, we've got 3,356. Let's see if we are correct. We are! All right. This was a quick one. This might have been our fastest so far. Let's take a look at the leaderboard. Again, I'm not expecting that we got in the very top of any... Okay, so we're actually a little slower than yesterday. But, you know, this is still a pretty good one. Still a pretty good result. And again, we're not trying to be the absolute fastest, although having a high rank is a little feather in our cap. But yeah, you know, talking about this, I think we see a lot of puzzles like this where what we're trying to do is basically just set operations, you know, that you can, you know, remember from math class. And part 1 here was to take the union of all the answered questions within a group across all the different people. So that's like a set-wise OR. It's anything that's in either one set or the other or both. And because we chose to represent the set as a field of bits within this 32-bit integer, each letter that designates a question is a different position in that bit field. Just bitwise OR is equivalent to the set OR. And very similarly, in part 2, we want to get an individual person's answers, you know, so we build up, we set the bits for each question that they answered here in this person answers field. And then instead of taking the union across all of the people, we want to take the intersection across all of the people in the group. And so for that, we use bitwise AND, because the bits have to be set for each of the people. So it has to, only if it's set for all of the individual person answers does the bit ultimately stay set in this answers field. There are other ways we could have approached this problem. We absolutely could have done this with set-based containers, where we, like just absol flat hash set, or in the standard library, standard unordered set. And for the keys, we could have used the individual... I'm sorry, my volume got messed up a little bit. I might have been quite quiet for you, and I just adjusted it back. But to get back to my thought, we could have used a container like standard unordered set or absol flat hash set, and use those characters A through Z as the keys in that, and then we could have you know, done set-based operations on those set containers. That would have been an equally valid solution. It would not have performed as well, though. Like, honestly, twiddling these individual bits is about as fast as you can get on this. I mean, maybe we could have done something crazy to make the parsing even faster, some kind of like crazy SIMD operations or something. But honestly, like, when you have a set problem this simple and you know that there's only 26 possible elements and you can parse them so quickly into the individual bit fields, just twiddling the bits is super fast. I think the solution is relatively simple, too, if you're used to thinking about bitwise arithmetic, and it was really easy to write this way. But using that container-based approach, if you had to have, like arbitrary strings, you didn't know what they were ahead of time. They could have been different length. They could have been, there could have been hundreds or thousands of questions. You would want a different solution that scales up better, and just twiddling bits like this isn't necessarily the best answer in that case. But given the parameters of the problem, I think that we found something that was both really fast to write for us as programmers and really fast for the computer to execute. So yeah, I'm pretty happy with today's solution. It will be going up on, I will be posting it up to the GitHub repo soon. Remember, that is, I'll put it on the screen right now, at github.com/craig-chasseur/AOC2020. The recording of this stream will also go up on my YouTube channel. That's youtube.com/spoonboy42. Thank you to everyone who joined tonight, everyone watching the stream, and everybody watching the replay later. We will be back here tomorrow night on Sunday. Same bat time, same bat channel, starting at about 10 minutes before 9 p.m. here on the West Coast. That's 10 to midnight if you're on the East Coast of the U.S. Your local time zones may apply. But thank you to everybody for joining the stream, and we hope to see you again soon. Bye-bye.